Welcome everyone to the first presentation of a series dedicated to my running dashboard tool development project. Um, Before I dive into the presentation, I want to do a brief introduction. So I'm Justin Campbell, computational engineering alumni from UT Austin. Program is an interdisciplinary degree in computer science, statistics, and mechanical engineering. I have 4 years of experience in data science and software development roles, where I've used my background in computational science and engineering to build back-end systems, improve data science workflows, and perform research studies. Some highlights of my work accomplishments include developing a cost estimating relationship tool to streamline the end-to-end model development lifecycle, improving model turnaround time, maintainability, and transparency. This involved refactoring what was an Excel-driven cost estimation workflow into a Python-based Python SQL pipeline with Microsoft SQL server persistent storage. Uh, Another one I want to touch on is inferential statistical analysis study that I performed, defense contract cost performance. The purpose of this was to strengthen leadership's ability to monitor program risk and prioritize oversight efforts by identifying indicators and rules of thumb pertaining to cost performance. So on this slide, this is a brief depiction of the technical toolkit that I've become familiar with through my educational background and job experience. I'm not going to touch on everything, but it's broken down into a few categories here. So emphasizing both compiled and scripting languages, data science and analytical libraries and packages, cloud and DevOps tools to include distributed computing software, version control, AI-assisted technology, and databases and project management tools, both relational, non-relational, as well as SDLC project management frameworks such as Agile and Jira. Okay, so transitioning to the scope of the presentation. So why perform requirements analysis for the project? Um, So firstly, with this project being developed as an individual effort, with no formal requirements, milestones, or deliverables provided by a customer or stakeholder, I could benefit from performing a comprehensive requirements analysis to, generally streamline the unbounded list of requirements or initial ideas into a subset that is more timely and achievable for myself. Um, so this can be kind of expanded into three purposes under the hood. So as I talked about, constraining the scope into a list of requirements that are more achievable and timely. It's also important to categorize the requirements into needs and wants to better prioritize the development effort moving forward. And then also, there's an interest in investigating trade-offs and implementing requirements on the development effort and the project management workflow to be aware of future implications relating to future design, development, and testing decisions. Okay, so how was this requirements analysis performed? So breaking down the steps, firstly, an initial review of the requirements was performed, and those deemed like the most important or necessary for the scope of the project were down selected as final and segmented away from those for further consideration. Then amongst the requirements for further consideration, trade-offs regarding the likely impact of implementing those requirements on the development effort and the project management workflow were considered. From here, trade-offs for each requirement were used to establish trade spaces by requirement type, i.e. technical needs, technical wants, functional needs, and functional wants. These trade spaces were used to convey trade-offs impacting the requirements at that category level to examine broader trade-off coverage on requirements at the category level. So, to what degree are the requirements as a whole impacted by these trade-offs? Are these trade-offs more localized to specific requirements, or do they affect category requirements as a whole? From here, insights from the trade spaces were used to down select requirements into final technical functional needs and wants designations, where some needs were reprioritized as wants and vice versa. And then lastly, requirements decision matrices were developed to visualize the association between needs and wants and the likely technical difficulty in satisfying those requirements. So what goes into that from a technical standpoint? So this slide is used to visualize the top-down requirements analysis process that I described on the previous slide. So at project inception, I documented 26 unique requirements into technical and functional categories and compartmentalized them into needs and wants based on initial priority designation. I performed a quick review to identify 8 requirements that I determined were um, most important to the project, effectively down selecting them as final without considering trade-offs. This produced this breakdown of 18 requirements as you see here. Um, and then to further down select these requirements, the next step was to establish trade-offs for the individual requirements here, considering properties like user experience, performance, and maintainability. From here, overarching trade spaces were developed for each requirement type. Um, And then using that information, trade space analysis was performed, down selecting requirements as needs, wants, or out of scope, using these insights. So then this produced this updated breakdown of requirements. So we have 4 technical needs, 5 technical wants, 3 functional needs, 3 functional wants, um, one requirement that can be broken down into subsets that spans both needs and wants, and 2 that were deemed out of scope for this project. Then the 8 final requirements that were initially down selected were added back into the list, producing this final breakdown of requirements moving forward in the project. Um, and then lastly, requirement decision matrices were developed to visualize the final categorization of requirements and better convey priorities moving forward. Um, so to track the steps of the analysis on a requirement level, we can drill down to an example requirement here and walk through each step of the analysis process. So taking the first functional requirement, interactive visualization features in the GUI as an example, here we have a long description that addresses the scope of the requirement through a brief mention of trade-offs, as well as the likely impacts of implementing or not implementing the requirement on the system. So this is effectively an unstructured summary of the expected impacts. So to read through briefly, enabling visualizations that support interactive zoom, pan, and other features improves user experience, increasing use cases and customization of the dashboard, allowing for drill down investigation of trends, but this would coincide with an increased development time, reduction in UI responsiveness, which could be significant considering that could be too significant of a trade-off, especially considering that the user can use native features in their browser or desktop image viewing features to accomplish the same goal of interacting with the data. Um, and the next section, we have a listing of the core trade-offs. So we have things like user experience quality, use case coverage, dashboard customization, development time, and UI responsiveness. And then here in the trade-off summary section, we have the strengths and limitations of the implementation of that requirement, which effectively takes Here I'm effectively taking the unstructured summary and breaking it down into easily readable segments. So t again, touching on strengths like improved use case coverage and user experience quality, conversely increased development time and reduced UI responsiveness. And then this last section here on the right, we have the trade-off compromises. So it's taking it a step further, and now we're listing the associations between how increasing one property impacts the other properties. So increasing user experience quality coincides with increase in development time indirectly and a decrease in UI responsiveness, etc. So step two was to review trade-offs for requirements by category. So again, technical wants, technical needs, functional wants, and functional needs. And this was performed by developing trade spaces that span trade-offs and the requirement for each of those categories. So in other words, for each requirement type, it was determined what the most important trade-offs were as a whole, and um, a development of how these trade-offs pulled on each other as a whole across that category, the relationships, and essentially mapping those into a two-dimensional space to better visualize them was the scope of this step of the analysis. Um, so here on the right side, we have a compromise schematic for feature capability. So, for example, user capability would pull on development time um, because it would indirectly involve more of a development effort to increase use case and user interaction. Would also pull on UI responsiveness because the greater the use case, likely the less responsive the UI would be. And similarly, UI responsiveness will pull on development time. Um, so yeah, the importance of this diagram, again, it conveys how these most important trade-offs for the requirement category pull on each other to take the analysis a step further and look at it, um, at a broader level across all of the requirements for that category. And here we have a listing of what source requirements are covered. So yeah, so amongst these this requirement space, we have the interactive visualization features that we've been talking about in this example, but we also have others that are impacted by this feature space, such as global time range selector, so the enablement of a widget that allows for a global update in the time range of all data, metrics, KPIs, as well as charts that are visualized in the UI. Drag and drop upload feature to enable the user to manually drag GPX files from their local machine into the UI as an alternative to a local repository file path being used. And then the fourth would be a configurable settings panel, which would be another feature in the UI that enables the user to globally or locally update settings like the time range selector. Okay, and then step three, um, requirements were down selected using insights from the trade space analysis. So continuing again with this example of interactive features in the GUI. Um, an important note is that this has implications on the feature capability space. Ultimately, the decision can be briefly described here. So, since enabling interactivity in the visualizations will likely add little benefit to the utility of the dashboard, would decrease the UI responsiveness, require additional development time, and can be substituted for native image viewing tools. This requirement's being deprioritized or being down selected as a want, time permitting. An identical process, again, was used for the other three requirement categories and associated um, trade spaces. So in this slide, we have one of two requirements decision matrices. Specifically, the technical requirements decision matrix. So this is used to visualize the association between customer satisfaction level, so needs and wants or priority level, and technological differentiation, easy versus hard to accomplish technically. Therefore, this visualization takes, one-dimensional listing of requirements by requirement type and maps it into a two-dimensional space where requirements can be more succinctly and concisely viewed and prioritized moving forward. So I won't read through all the requirements, but I can go ahead and start with what we have here in the first segment or first partition. So technical requirements 1 through 3 pertain to the tech stack. So Python being used as a programming language, Cursor is the ADE, and GitHub for version control. It's considered easy to do because the developer myself has a lot of experience with those specific tools. Next, we have a couple requirements that pertain to error handling for file types and fields. Um, this would likely be as simple as an implementation of a couple of functions or a class with a couple of functions to perform basic error handling on GPX files that don't need significant parsing to begin with or error handling to begin with. The use case is the user isn't physically developing these files, right? They're being auto-generated by Garmin, and so unless the user incidentally or unordinarily modifies the content of the file, then it's not anticipated that any errors will be encountered when ingesting the file. And then we have custom file upload into repository file path as another need that's easy to accomplish. Um, so we can take a look at some of the more technically difficult requirements. So comprehensive system testing. So that's an umbrella to refer to unit testing, system integration testing, front end and back end, user acceptance testing, et cetera. So there's certainly a lot that goes into that and will be technically difficult to accomplish. We have deriving computed fields from Garmin files, which could be challenging to accomplish. This is my first time parsing a Garmin file, so there may be a learning curve with this. And then we have machine learning driven requirement implementation, such as personalized forecasting models and tailored race time predictions, which are some of the most important, like personalized features of the tool to give users an understanding of how they're performing and what targets they can accomplish within a reasonable time. So they're considered needs, and a lot goes into developing training machine learning models. So that will certainly be a hard to do task. Um, and then looking at some of the wants, we have error handling for invalid UI inputs. Again, it's considered easy to do because um, as the tool stands right now, I don't envision there being many variations of user input in the UI to either filter or generate models or charts. Um, and it's considered a want because um, ultimately ultimately the model should perform a lot of these should ingest and process a lot of these inputs implicitly. So I don't see an immediate use case for needing extensive error handling for UI inputs. And then data persistence for future launches, that is considered a want. Ideally, the tool doesn't need persistence to function. It can, um, as a personal project, um, it's not the performance of the tool isn't going to be impacted much by whether the data is persisted or not. So it's likely going to be it's designated as a want, and will likely be easy to implement as well. And then in terms of the harder to accomplish wants, we have some additional machine learning driven requirements such as tailored load insights, anomalous run reports, and personalized target race states. And then here we have the functional requirements. So in terms of the easier to accomplish needs for the project, we have the project management workflows, Agile Kanban. So myself, I have experience with using the Agile Kanban workflow. Then we have GitHub versioning and releases for the Mac OS. Um, and I've been developing on a Mac OS for a while and have used GitHub extensively, so I'm very comfortable with it. So it's considered an easy to accomplish requirement for the project. We have a dashboard as a standalone application, meaning the dashboard can be launched separately from, let's say, from a terminal by invoking a bash script or otherwise or an executable. We have the calculation display of common metrics. So metrics that are incorporated natively into the Garmin file data. So properties like heart rate, BMI, VO2 max, etc. And then shifting gears to the harder to accomplish needs, we have the single page dashboard display. So this is considered a harder to accomplish task. There's a lot of factors that will be considered in developing a single page dashboard display. Um, this is one of the primary use cases of the tool. One of the purposes is to develop a more consolidated display of model output and visualizations, ideally in a single page that allows for a user to quickly navigate between output and make associations without having to, let's say, render separate states of the UI or, use scroll bars to, move from one side of a UI through another to make associations. So this will involve a lot of considerations like UI space, responsiveness, and so forth. So it's considered hard to do, but it's very much a need because again, it's one of the primary thrusts of the project as a whole. Then we have optional GUI data export. So a decision was made to not automate the mass export of GUI data, model metrics, visualizations, in each state that's rendered in the GUI, because that would slow down the performance of the tool, possibly causing it to freeze and decrease the user experience. So that's where this requirement comes in, is enabling an option for users to output some subset of desired GUI data based on their use case or what they're most interested in storing. This will be hard to accomplish because factors like, again, like user interface, available space in the user interface, navigability, and performance considerations as well. And then we have the calculation display of common indicators and KPIs like your VO2 max, lactate threshold. You have others like lesser well known would be for the next section, but yeah, predominantly like VO2 max, lactate threshold, and other indicators of running performance. This will be harder to do because it may involve um, some calculations behind the scenes to determine what um, appropriate thresholds are for the user given their specific activity data, historical activity data. And then transitioning to the wants, we have the plot interactivity that we looked at with the example that we drilled down on. Um, it would be one of the benefits of it would be that enabling plot interactivity through, zoom, pan, and other features could be as simple as a single line of code where you're setting a specific argument value to true or false, for example. So the implementation would be, the implementation could be pretty straightforward. But, as we looked at previously, there are other factors that, like UI responsiveness, to include a couple others that from which I determined to deprioritize it from a need to a want. But yeah, time permitting, that is something that could be revisited. And then we have drag and drop file upload. Um, that would be a nice to have. It's not necessary for the behavior of the tool. Again, the native feature will be associating um, associating the tool with a local file path, a repository file path where the user uploads historical files. The tool directly knows exactly where to look for those files to ingest at runtime. Then transitioning to the hardware accomplish requirements, we have the global date range selector for the UI that we discussed briefly earlier. So it would be, while it would be nice to have it would be nice to have a feature where with the click of a button or the activation of a slider or the input of values in two entry fields, you could constrain the date range of data that's output in the window. However, that doesn't impact the use case necessarily of the tool, as the user can infer that directly by looking at the charts. With the model data itself, um, you know, technically that does add an additional use case because some of the, indicators and KPIs don't, um, you can't infer what the range of values for those metrics would be from the output. They'll likely be, numerical values with, maybe color-coded indicators or bars that characterize, for example, good, moderate, and poor designations. So that would be an example where this could come into play, but for the most part, this won't enhance the user experience much. And so it's being, prioritized as a want. Um, and then we have the calculation and display of uncommon indicators and KPIs. So expanding on what we looked at here previously, this would include um, some additional, um, some additional indicators like heart rate variability, hill score, um, other properties that may be native to Garmin running activity files or calculated from them, but aren't as commonly used in forecasting um, a runner's performance or target date that would involve some literature review and research. So with more effort, it's considered a harder to do and more technically challenging implementation. Okay, and the last slide. So after performing the requirements analysis here, the next step that I've started working on is to begin ideating, you know, preliminary system designs through black box diagrams to characterize inputs, outputs, internal processes in the application and its subsystems. Secondly, flowcharts that convey the workflows of common use cases when operating the system, following the user from initial launch through dashboard display and data export. Thirdly, system architectural diagrams that illustrate the technical components within and between subsystems and how they integrate together. And then UI designs that convey the visual layout on a state-by-state basis for common use cases. So after performing this, then we'll transition to feasibility analysis studies to identify and down select competing alternative technical design ideas, including software libraries and frameworks. So as narrow in scope as individual libraries and frameworks, to broader system architectural designs, from which to ultimately develop detailed system designs. All right, that's it for the presentation. Thank you for watching.